Cambridge IGCSE 0625/42, February-March 2024, Paper 4, Theory, Extended. Full paper walkthrough. Figure 1.1 shows a speed time graph for the first 5 minutes of bus journey. Describe the motion between 0.9 minutes to 2.9 minutes. So 0.9 minutes, this is 0.9 minutes, and 2.9 still here. So as you can see, the speed is constant. So the motion between 0.9 minutes to 2.9 minutes is constant speed. So 2.9 minutes to 3.5 minutes. As you can see, the speed is decreasing, and the speed is decreasing uniformly. The gradient is the same. So it's going to be uniform deceleration. From 3.5 minutes to 4.5 minutes, you can see that the speed is 0. So the bus is stationary. Another bus travels at a speed of 8.9 meters. The brakes apply a constant force and the bus stops in a distance of 23 meters. This bus has a mass of 18,000 kilograms. Calculate the kinetic energy of the bus before the brakes were applied. So before the brakes were applied, the bus was traveling at a speed of 8.9 meters per second, and we know the mass of the bus is 18,000 kilograms. So we can use the equation for kinetic energy, and we can work out the kinetic energy. And this would give us 7.1 times 10 to the power 5 joules. Calculate the force applied to stop the bus. Okay, we have to find the force. We know the energy of the bus is 7.1 times 10 to the power 5, and we also know the stopping distance, which is 23 meters. So we can use that to calculate the force. We can use work done is equal to force into distance, and using this equation we can work out the force. And that would give us a force of 31,000 newtons. And that's it for question number 1. Question 2, part A. Define impulse. Impulse is a product of force and time. Figure 2.1 shows a rocket and its exhaust. The exhaust gases are emitted from the rocket with a velocity of 1400 meters per second and at a rate of 2800 kilograms per second. Show that the force exerted on the rocket by the exhaust is 3900 kilonewtons. State an equation you would use. Okay, so we have the mass here, and we also have the velocity, and we are asked to find the force. So we know the impulse is equal to mv minus mu, which is basically the change in momentum, and we also know that impulse is equal to force into time, and we can combine these two and we can find the force. Force is equal to change in momentum divided by the time. And this is the answer for this part of the question. Calculate the maximum mass this force can lift from the ground. Ignore the air resistance. Okay, we are asked to work out the maximum mass. So for that we can use this equation. We know the force. We can calculate the force using change in momentum. And I basically missed this part. We are supposed to substitute and show that this is the answer. So that would be this is the mass, 2800 multiplied by 1400 and divided by 1 second, because it's given per second, and that would give us, and that would be 3,900 kilonewtons. We can use that to calculate the mass in part 2. So we know that the weight is 3,900 newtons, and we can use that to work out the mass. So mass is equal to the weight, that's the force, divided by the acceleration of free fall, that is 9.8, and that would give you 3.98 times 10 to the power 5. That's 4 into 10 to the power 5 kilograms. And that's it for question number 2. Question 3. A car has a weight of 13,000 newtons. The car is supported by 4 tires. The area of each tire in contact with the road is 0.016 meters squared. Calculate the pressure on the road due to the weight of the car. So pressure is equal to force over area, and we know that the car's weight, which is the force in this case, is 13,000 newtons divided by the area, and the area for each tire is 0.016 meters square, and we have 4 tires, so you have to multiply that by 4, and that would give us the pressure, and that gives us a pressure as 2.0 times 10 to the power 5 pascals. Explain in terms of particles why the air pressure in the tire increases when the tire travels along the road. As the car travels along the road, the friction between the road and the tires causes the temperature of the air inside the tires to increase. This increase in temperature makes the air particles inside the tire move faster. The faster moving particles collide more frequently with the greater force against the walls of the tire. Since the force on the tire walls increase and the area of the tire remains constant, the pressure inside the tire increases. This is a 4-mark question, and these are the 4 points you are supposed to cover. Why the air pressure increases when the temperature increases is a very frequently asked question. This is a little bit different. Here the temperature is not mentioned in the question, but you would have to understand that as the car travels, the friction between the road and the tires would heat up the tire. And so it's important to remember these points as it's a frequently asked question. A gas cylinder contains helium gas at a pressure of 2 times 10 to the power 6 pascals. A volume of 0.026 meter cube of the compressed gas is released into the balloons. The balloons contain 0.015 meter cube of helium gas at atmospheric pressure. The temperature remains constant. Calculate the maximum number of balloons that can be filled. So we know the volume of each balloon and the pressure. We are also given the pressure of the helium gas inside the cylinder and the volume of the gas that is being released into the balloons. So we can use P1 V1 is equal to P2 V2, and we are supposed to find the V2, and after finding the V2 we can work out the number of balloons. V2 would be 0.52, and we know that one balloon is 0.015 meter cube and 0.52 meter cube would be X balloons. We can use this to figure out number of balloons that can be filled. So X would be equal to, and that would give us 34.66. That would be 34 balloons. Question 4. Define specific heat capacity. Specific heat capacity is the thermal energy transferred per unit mass per unit temperature change. A volume of 0.024 meter cube of oil is heated in the pan for 7 minutes. The temperature of the oil increases from 20 degrees Celsius to 180 degrees Celsius. The density of the oil is 910 kg per meter cube. The specific heat capacity of the oil is 2000 joules per kilogram degree Celsius. Calculate the mass of the oil in the pan. So we know the volume and we also know the density. So we can use these two to work out the mass. We can use the equation density is equal to mass over volume, and we can calculate the mass. And that gives us 2.184. That's 2.2 kilograms. Calculate the energy required to increase the temperature of the oil. So we can use this equation. E is equal to mc delta theta, the change in temperature. We know the mass, that's 2.184, and the specified capacity is 2000, and the temperature is 180 minus 20, and that would give us the energy, and that's 7 times 10 to the power 5 joules. Calculate the power required to supply the energy calculated in part B. So to calculate power, we have to divide the energy by the time. So we know that this temperature change takes 7 minutes, and we know the required energy, so we can divide it by the time. I am converting the minutes to seconds here, and that's 1666.6, 1700 watts. That's it for question 4. Question 5. Table 5.1 shows a region of an electromagnetic spectrum. Complete the second column of the table with the region of the electromagnetic spectrum used for each application. Choose the correct regions in this list. Each region may be used once, more than once, or not at all. Okay, so the first application is cancer treatment, and the region is gamma rays. Then we have Bluetooth connection, and that's radio waves. For optical fibers, it's infrared. For security marking, ultraviolet. And for sterilizing food, again gamma rays. And wireless internets is microwaves. It's important for you to know the uses of these regions, so it's good to know at least 2 or more uses of each of these electromagnetic spectrums regions. State the approximate speed of radio waves in air. The approximate speed of radio waves is the same as the speed of light, so it's 3 into 10 to the power 8. Part B. Figure 5.1 shows successive crests of a wave after a plane wave has passed through the gap. On figure 5.1, draw 3 successive crests before the wave reaches the gap. So we are supposed to draw 3 successive crests before this. So we have to see the wavelength here, and we have to draw straight lines that have approximately the same wavelength. So it's important that the gap between these 2 lines are the same. Figure 5.2 shows a much wider gap. A plane wave of the same wavelength as B1 is incident on the gap from left side of the barrier. On figure 5.2, draw 3 successive crests of a wave after the wave has passed through the gap. So here the gap is much bigger than the previous part, but the wavelength is the same as the previous part. So we would have to, so here as the wavelength is bigger, there won't be as much of a bend. So it would look something like this. But also on this part, make sure this wavelength is the same. And that's it for question 5. Question 6. Figure 6.1 shows a full-scale diagram of object O and its image I produced by a converging lens. The lens and its position on the principal axis are not shown. Okay, so the lens is not shown, but this is how a converging lens looks like. On figure 6.1, draw a single ray to locate the position of a center of the converging lens. So we want to locate the position of the center of the converging lens by drawing a single ray. So we can draw a ray from the object to the image, and this is the center. So we're supposed to draw a line and label it as L. So this is the center of the converging lens. Part B, determine the focal length of the lens by drawing another ray. So in order to determine the focal length of the lens, you're supposed to draw another ray from here to the lens, and a ray from here to the image. And this point here is the focal point. So if you measure this distance, and that would give you the focal length. The object is moved 2 cm closer to the lens. State 2 changes to the characteristics of the image. So the object is originally here, and this object would move closer to the lens. So the object, say it's here. This is the position of the new object. And if you draw a line through the center, and if you follow this line through the focal point, we can see that these two lines don't meet. But when we extend them behind, they would meet as this point. Okay, so here we can say that the changes to the image is that the image is virtual and the image is upright, but here the image is inverted and the image is real. So that's it for this part of the question.